So let's do a couple of comparisons. We're going to compare a proportional and a non-proportional relationship to each other. So our first one says a laser tag league has the choice of two arenas for a tournament. In both cases, X is the number of hours and Y is the total charge, and we're going to compare and contrast these two situations. So compare and contrast means say something that is similar and something that is different. So arena A gives us an equation, Y equals 225X, and arena B gives us a graph. And right off the bat, the thing that we're looking for is, are these proportional or non-proportional relationships? And arena A is a non-proportional relationship. How do we know? Because there is no constant added or subtracted onto the end of this equation. If this was a proportional relationship, a non-proportional relationship, we would have something like y equals 225x plus 5 or minus 20. We would have some kind of constant on the end here, and we don't. We just have y equals 225x. So you would say this is a non-proportional, and the constant of proportionality is the number that is in front of the x, which in this case is 225. That means that is the rate or the slope, what it is changing by. So we're measuring how much this place costs. 225x means 225 times the number of hours. So we would say that this place costs $225 per hour. Okay, so it's non-proportional. It costs $225 per hour. Let's take a look at the next one. So arena B is a non-proportional relationship. How do we know that this one's non-proportional? Well, the way you can tell from a graph is, does it go through the point 0, 0? And this one does not, because there's the origin and the line does not go through the origin. So where does it start? It starts right here in between 0 and 100. So I think it's reasonable to say that it has a y-intercept of 50. So y-intercept of 50, which makes it non-proportional. And then we want to know what the rate of this one is. Now, the easiest way to tell what a rate is from a graph is to count the rise over run. So let's go ahead and do that. Let's count rise over run. To count rise over run, you just pick any 2 points that you like. I'm going to use this point, the y-intercept. Let's not use blue because our line is blue. Let's pick green instead. So let's use the y-intercept. And I could use this point right here, but I'm not going to use that one because it has an x of 0.5. I'm going to try to use whole numbers. So let's use this point right here at 1. Okay, so what's the rise from here to here? What are we going up right here? So we started at 50 and we went up to 250. In between 200 and 300 is 250. So if we went from 250 to 50, that's a rise of 200. And then our run goes from 0 to 1. So we have a run of 1. So our rise over run is 200 over 1, which is just 200. Okay, so what does this mean? It means we have an initial fee of $50. That's what the y-intercept of 50 means. Initial fee of $50. And then it's only $200 per hour. So that initial fee is what makes it non-proportional. And then $200 per hour. So arena A, there's no initial fee, but it costs more per hour. Arena B, there is an initial fee right up front, but then it is cheaper per hour. So which one do we want to pick? Might depend on how long we plan to be there. If we plan to be there a short number of hours, maybe one arena is better than the other. That's something that we're going to discuss very, very soon, is if we're given a choice between one that has an initial fee and a lower cost versus one that has no initial fee and a higher cost, how can we decide which one's better? That's coming up very, very soon. Let's do one more of these comparisons. All right, so here we've got Jessica. She's remodeling and she has a choice of two painters. And in both cases, X is the number of hours and Y is the total charge, just like on the last one. And we're going to compare and contrast these as well. So painter A gives us an equation, Y equals 45X. Just like the last one, there's no constant added on to the end here. So this one is a proportional relationship. And the constant of proportionality is $45, which means they're charging $45 per hour. Okay, painter B does have a initial fee, and we can see from the table right there, 0.20. So it doesn't go through 0.0, it goes through 0.20. So 0.20 is the y-intercept, which means that this is non-proportional. Non-proportional relationships do not have the 0.00. So there's an initial fee of $20. But then how much is this painter charging per hour? So let's just look at the first hour here. So when we go from 0 to 1 hour, so that first hour that the painter is working, the cost goes from $20 to $55. So his initial fee was $20, and then he charges us for that first hour. How much does he charge for the first hour? Well, that's a pretty simple subtraction problem. 55 minus 20 is 35, and that was for that 1 hour. So $35 per hour. Okay, so painter A, no initial fee, just $45 per hour. That's our proportional relationship. Painter B, $20 initial fee, but only $35 per hour. Again, it seems like one of these painters would be better if we just needed a short amount of time painting, but if we needed a longer amount of time, the other might be better. And that's something we're going to learn in the very near future, is how to tell which one would be better for us to hire for a short amount of time versus a longer amount of time.